All right, so I thought I better go ahead and finish up that problem we stopped on so fast last time. Um, I was going to wait on that, but I thought, well, let's just go ahead and do it. X prime is 1 minus x squared. Y prime is equal to 3 minus x minus y. And we're looking for a method of Nullclines to analyze our solution. Okay, so now again, the way to start is by setting each of our functions equal to 0. So for the first function, we just get x is equal to plus or minus 1, and those are two vertical lines, right? And in the second equation, we have y 3 minus x minus y equals 0, or y equals 3 minus x. Okay, and so our two lines here, this is x equals 1, x equals minus 1. Let's see if I can draw that decently now. Last time I didn't draw it very well. Okay, that's pretty good. Okay, so this is our y equals 3 minus x equals 1, x equals minus 1. Good. Now where are the equilibrium solutions? Remember that our equilibrium solutions has to be where each of these is equal to 0. So it's where these lines intersect this line. So it looks like we have two equilibrium solutions, one right there and one right there. Good. And now let's see if we can figure out what our directions are here. Okay, so in this case, where our graph is split into three pieces, right, I want to think about is the derivative, so here x prime is equal to 0, x prime is equal to 0. What's happening on the other three intervals here? Well, if we pick an x between negative 1 and 1, right, our derivative is 1 minus x squared. What does that look like? I guess I could graph that over the top. 1 minus x squared is an upside down parabola, right? So therefore, between these two, x prime is going to be positive, and then x prime is negative, and x prime is negative. And so I could even write that up here just to remind myself. X prime is negative, and between here, x prime is positive, and here x prime is negative. Good. And then how about for this line? Along the line, that's where y equals 3 minus x. But otherwise, we're looking at 3 minus x minus y. That's our function, right? And so the line splits the plane into two pieces. So what is the value of the line below the graph, below the line? If I put an xy below the line, it's not going to be equal to 0, but it will be positive or negative, right? So for example, if I put in 0, 0, I get a 3 out. And so this function is positive below the line. And so I won't write that. I'll say y prime is positive below the line. And so that means y prime is going to be negative above the line. So for example, just to double check that again, you could try plugging in the value 0, 4. And so if I put in 0, 4, I get a negative value here for my derivative. Good. All right, are we ready to do the rest of our analysis now? Let's see, along x equals 1, or along each of the vertical lines, x prime is 0. So that means what? That does mean I'm just going straight up and down. So I just need to figure out if that's going up or going down. And so from this, you can see what's happening, right? These are going to be going up. These are going to be going down because of that. Similarly, these will be up. These will be down. Good. And so on the line here, our y prime is equal to 0, which means that we're just going straight side to side. So we just have to figure out if we're going left or right, and I've already figured that out. So here I'm going left because those are under the, or that's in this region. In this region I'm going to be going right, and then in this region left. Good. All right. So what do we see there? What's going to be the general pattern here? Well, we see that, for example, in this region, our x prime is going to be positive, so we're going to be moving up. No, we're going to be moving to the right. And then what's our y prime going to be? Below the line. So we could say, like, maybe I'll write A here. In part A, we would be going up and to the right. How about in section B there? What would happen in B? In B, we're going to be going down and left. Good. How about in region C here? In region C, we'd be going up and to the left. Okay, and so you kind of see what's happening here. So these are going to be coming this way. These are going to be coming this way. So what would you expect this to be? I have a feeling that's going to be a sink. Yeah, how about this one? I have a feeling that's going to be, that's not going to be a sink. It looks like it might be a saddle, right? Because then solutions will be coming in this direction and coming around. So I'm thinking that this may be a saddle because it's converging in one direction and not in the other. Okay, of course, these are not eigenvectors here, right? These are not eigenvectors, but they are curves where you have the same slope. Okay, so then to see it all together, you would want to just plot this on the online plotter, and then you would have a better idea of what's happening. Okay, so I'll just stop there for this example. I just wanted to make sure I finished this one up. I didn't want to leave that undone. Good. So you could also figure out what's happening in the other regions as well, just by doing our same analysis. Excellent. I'll talk to you later.